All right, let's do this. Your Unit 9 Transformations exam is coming up, and this is your final, super fast review. We're going to cut through all the noise and focus on exactly what you need to know to crush this test. Ready? Let's jump right in. So, are you ready to finally master the flip, the slide, and the turn? Think of what we're doing here as building your transformation toolkit. We're going to make sure you've got the three big tools, reflections, translations, and rotations, completely locked down. This is all about getting you totally prepped to ace this thing. Okay, first up, transformations, the ground rules. Before we start flipping and sliding shapes all over the place, we got to get the language right. Seriously, nailing the vocabulary is like half the battle. It's the foundation for everything else. So the absolute number one term you have to know is rigid motion. You see the official definition here. It's a transformation that preserves the lengths of segments and the measures of angles. Okay, so what does that actually mean? In simple terms, it means the shape can move around, but it doesn't stretch, shrink, or change size at all. It stays, well, rigid. That's the key. And check this out. These two images show you exactly what we're talking about. Look at the one on the left, labeled number 1. See how the shape got all stretched out? The side lengths are totally different. That is not a rigid motion. But now look at number 2 on the right. The triangle moved, yeah, and it's facing a different way, but the shape itself, the side lengths, the angles, they're exactly the same. That's a rigid motion, and that's going to be our focus. All right, tool number 1 in the toolkit, reflections, or as you should think of it, the flip. It's really that simple. You've got a line, like a mirror, and the shape just flips right over it to a new spot. Okay, now this slide right here, this is pure gold. Seriously, screenshot this, write it down, whatever you need to do. This is your cheat sheet for the rules of reflection. You've got to have these memorized cold. You know, if you reflect over the x-axis, the y value changes its sign. Over the y-axis, the x value changes. And then you've got those two special ones, y equals x and y equals negative x. So let's see how this actually works. We're taking that line segment FG and flipping it over the line y equals x. So point F, which is at 3, 0, becomes F prime at 0, 3. They just switch places. And look at that little handwritten pro tip on there. Change signs and swap numbers. That's such a good way to remember it. For y equals x, you just swap them. For y equals negative x, you swap them and you flip the signs of both. Little tricks like that are going to save you so much time on the test. Okay, so what happens when they throw a curveball? What if they give you the original shape and the reflected one, but they don't tell you what the line of reflection is? You have to find it. Well, the secret is right here. The line of reflection is always the perpendicular bisector of the line segment that connects a point to its image. And here's the recipe for how to do it, broken down into 4 easy steps. 1. Find the midpoint of the line connecting a point to its image, like from A to A prime. 2. Find the slope of that same line. 3. Do the whole opposite reciprocal thing to find the perpendicular slope. You know, flip the fraction and change the sign. And 4, use your point slope formula with the midpoint and that new perpendicular slope to write the equation of the line. If you follow these 4 steps, you literally can't get it wrong. It's foolproof. Okay, moving on. Tool number 2 in our toolkit is translations, aka the slide. And honestly, this is the easiest one of the bunch. There's no flipping, no turning. The shape just slides from one spot to another. That's it. Now, you're going to see translations written in 2 different ways on your test, and you got to know both. On the left, you have function notation. This tells you exactly what to do to the coordinates. So x, y goes to x plus 6, y minus 3. Pretty straightforward, right? Add 6 to x, subtract 3 from y. Then on the right, you've got vector notation. Those little pointy brackets tell you the same exact story. The vectors 6, minus 3 means move right 6 and down 3. 2 different languages, same exact meaning. And if you're trying to picture this, the marching band example is perfect. Think about it. When the whole band marches across the field, every single person moves in the exact same direction and the exact same distance. Their whole movement from one spot to the next can be described by just one vector. In this case, it's -12, -9. That's 12 steps to the left and 9 steps back. The whole group slides together. All right, time for our final big tool, rotations, or the turn. I kind of think of this one as the power tool in our toolkit, mainly because it has the most rules you have to remember. But don't worry, we're going to break it down. So for any rotation problem they throw at you, there are 3 things you absolutely must know. Think of it like a checklist. Number 1, what's the center of rotation? Where's the pivot point? Number 2, What's the direction? Are we going clockwise or counterclockwise? And number 3, how many degrees? Is it 90, 180, 270? If you have the answer to all 3 of those, you're golden. And you guessed it, here's another cheat sheet. This one is for your rotation rules when they're centered at the origin. And yeah, you just gotta memorize these. But look for the patterns, okay? For 90 and 270 degrees, the X and Y always swap places. The only difference is which one gets a negative sign. And for 180, that's an easy one. They stay put, but both of them get their signs flipped. Spotting those patterns makes it so much easier to remember. Okay, you've got the tools. You know the flip, the slide, and we turn. Now, let's level up and put it all together for some of those advanced honors level problems. This is one of my favorite parts, actually. Seeing what happens when you take a simple 2D shape and rotate it through space to create a 3D object. So, for example, take a look at this right triangle. What do you think happens when we spin it really fast around that vertical line? You get a cone. How cool is that? Okay, what about a rectangle? If you take a rectangle and spin it around one of its sides, yep, you get a perfect cylinder. And for the last one, if you take a semicircle and spin it around that flat edge, its diameter, you get a sphere. The whole trick to these problems is just trying to visualize that path the 2D shape makes as it sweeps through space. That path is what creates the 3D solid. Another big idea you'll see is rotational symmetry. This just means how many times can you turn a shape before it looks exactly like it did when it started. So this equilateral triangle here, if you turn it, it'll look identical 3 times in a full circle. So to find the smallest angle that works, you just take 360 and divide by that number of times. 360 divided by 3 gives you 120 degrees. Simple as that. Whoa, okay, we've covered a ton of ground. So let's bring it all home. Here it is, the entire unit, condensed onto one single slide. This is your final cheat sheet, the thing you look at right before you walk into that classroom. Let's do a lightning round. Reflection, that's the flip. Like across the x-axis, x, y goes to negative x, y. Translation, that's the slide. Right 2, down 4, that's x plus 2, y minus 4. And rotation, the turn, 90 degrees counterclockwise, x, y becomes negative y, x. Bam, that's it. That's the heart of this whole unit. So you might be thinking, okay, but why do I actually need to know this? Well, this isn't just a bunch of random rules in a math book. This is the code behind the world. Computer animation, the video games you play, GPS navigation, all of it is built on these exact transformations. It's all just really, really fast flips, slides, and turns. So as you finish up studying, just think about that for a second. Where else in your world do you see this math in action? You are going to do great on this test. You've got this. Good luck.